Technology in telecom industry is evolving faster than ever, and one such example is a 5G fifth generation technology. 5G brings new capabilities that create opportunities for people, for businesses, and for the society. Hi, my name is Rahul Kondal. I'm a seasoned telecom professional working in telecom industry for more than 17 years. Through this course, I would like to give you insights about 5G, its architecture, how it can be designed in an efficient way, how it is getting evolved as compared to its legacy technology, and how it can be deployed. This course is designed for any tech enthusiast who is willing to learn about new technologies in telecom industry, right from the basics to the advanced level, irrespective of their experience. We are covering a wide range of topics, starting with the overview of 5G, what are the different deliverables of 5G and the design goals of this technology. We'll touch base upon the architecture of 5G end-to-end, including radio access network, transport network, and the core network. We'll see how the radio access network, which is also known as a new radio in 5G, is getting evolved and what are the different new techniques that are introduced in 5G and all. We'll also look into how we can design an efficient 5G new radio, be it related to the coverage, capacity, throughput, or spectrum. We'll look into the other evolution that is happening in a radio access network, be it related to virtualization, cloudification, and cloud native networks. We'll look into the protocols and get a deep understanding through simulations about all the protocols in 5G. We'll see the different building blocks of 5G core network in detail and how the user and the control plane is getting separated end to end. We'll look into the call flow related to 5G in this particular section, and also the different identifiers related to the user as well as for the network. There are different deployment options that are available in 5G in conjunction with 4G or individually standalone 5G. We'll talk about that in more detail. We'll look into the different building blocks of telco cloud, such as the virtualization, orchestration, software-defined networking, edge computing. We'll also look into the integral part of 5G, which is advanced antenna techniques such as beamforming and MIMO. I hope you must be excited to get into more details of these topics. And if so, I'll see you in the next section. Stay tuned. Hi, welcome to the course of 5G. I'm really excited to take you through this course of 5G. And in this section, we'll focus upon 5G overview. We'll be covering different topics, right from the evolution of mobile networks, right from the second generation up till fifth generation. We'll look into the different standard bodies, such as ITU, International Telecommunication Union, and 3GPP, third generation partnership project, who are working towards evolving the overall ecosystem of 5G. There are different updates and release that are given by 3GPP, and with the advancement in the technology time to time, and there are different working groups who are working on the different subsets of the 5G ecosystem in 3GPP. We'll understand what exactly the 5G is and what are the different key capabilities and deliverables of 5G ecosystem. What are the different design goals as compared to what we have seen in 4G? There are way above and beyond design goals that are defined in 5G, along with the new use cases which we haven't seen so far by the legacy technologies. And these new use cases are contributing not only towards the people or the society, but also to the economy by adding around 1.3 trillion USD dollar that is estimated to be achieved by 2030 by 5G technology. We'll talk about the evolution of mobile network first. So there are three key areas which are defining the technology, such as the downlink and uplink speed, the latency, and the services that are being provided. In 1G, we have seen it's more about the analog services that were provided, analog voice. In 2G, it was more towards the digital voice and the text services. Then after there was in 2.5G, the GPRS with a speed of 384 kbps was introduced. In 3G, we have seen around downlink speed of up to 42 Mbps with a latency of 200 millisecond and providing some new use cases such as mobile broadband and multimedia. In 4G, we have seen new emerging use cases such as NB-IoT, and it was a faster mobile broadband with a speed of up to 1 Gbps and a latency as low as 100 millisecond. In 5G, there are many more new use cases which are not only restricted to the mobile broadband, but here it is being introduced with the ultra reliable low latency services and the massive machine-to-machine communication, and which has been not seen or leveraged so far in the previous legacy technologies. Let's go to the next section soon. See you there. Thank you. Hi, in 5G, there are different key deliverables and what exactly this 5G is meant for. So any technology who is actually first enabled has certain key focus areas. And here in this case, this particular technology is focusing on providing the better wireless connectivity. And this connectivity is providing in terms of the better speeds or the broadband, enhanced broadband, or in terms of the machine-to-machine communication, where it is massive number of devices are connecting to the network and being catered by 5G ecosystem easily, maybe in terms of millions devices per cell site. Then in terms of some critical time-sensitive services which will be delivered by URLLC, ultra reliable low latency communication in 5G. So there are three key areas where 5G is basically focused upon: eMBB, machine-type machine communication, and URLLC. Now these different services are enabling actually the different use cases. If we look in this particular diagram here, in terms of mobile broadband, so we can provide the fixed wireless access, or we are giving the mobile broadband services up to 20 Gbps in downlink. We are also providing 3D video or ultra high definition screens or 4K screens, which are demanding a very high broadband services or very high throughput. In that case, that is being delivered by 5G. 5G is also enabling, if we look on the right bottom, ultra reliable low latency services for mission critical applications such as robotic surgeries, e-health, self-driving. So V2X, which is vehicle to anything, that is being enabled by 5G, which was not possible so far in the legacy technology because we were not meeting that criteria of a stringent latency in that case, which is achievable in 5G. Augmented reality, which is again, we have to do something in a real time, that will be delivered by 5G. In terms of machine to machine type communication, we can look into the different use cases such as the smart city that can be enabled by 5G technology, smart home, smart buildings. So all these different new use cases which was not actually delivered by the previous or the legacy technologies, that can be easily achieved by these different focus areas of 5G technology. Hi, so in the previous slide we have seen the three key focus areas for 5G technology, but how it can be achieved, there are certain key capabilities that are defined by ITU. So they came up with the new generic term by IMT 2020, which will be designating the 5G key performance indicators. Before that, there was IMT Advanced, which was primarily used for the 4G technology. And here in this particular diagram, we can correlate and understand the comparison between the 4G and the 5G key capabilities. So until unless these different capabilities which are defined by ITU are not achieved, it will not be considered as a true 5G network. So if we look into the specifications defined by ITU in terms of a peak data rate, this is at the cell level, it should be 20 Gbps. We'll understand that how this 20 Gbps can be achieved with the different technologies and techniques that are there defined in 5G. We'll talk about that in the subsequent slides. But this is the cell level throughput which has to be achieved in downlink. But what about the user level throughput, that is 100 Mbps in downlink, that is defined by ITU. In terms of spectrum efficiency, how many number of bits per second per hertz are being transmitted, that defines the spectrum efficiency. And it has to be increased with time with any new evolution, because spectrum, we understand, is one of the costliest asset for any telco. So here we can see the target is to get 3 times more efficiency in spectrum in 5G as compared to that in 4G. Mobility, we have fast mobile users which can be catered upon. In this case, 500 km per hour, that can be catered by 5G as compared to 350 km per hour in 4G. The latency in 5G is being targeted as a 1 millisecond, and here in this case, this is quite a stringent requirement defined as compared to 10 millisecond in LTE or 4G. The connection density, again, in case of massive machine-to-machine type communication, where millions of devices to be connected to the cell site, that is possible in 5G, which was not possible in terms of 4G. Then in terms of network energy efficiency, because now the more focus is to utilizing the resources efficiently, and we understand the most of the OPEX part comes from the energy itself. Any reduction in energy cost in that case, or the introducing more energy efficiency, will help to enable a sustainable networks going forward. So here we are looking into these key areas. I hope you liked the content and the short lectures on 5G in this video so far. These are few of the lectures amongst 100 plus lectures captured in a comprehensive 5G course, which is available on learning platforms such as Udemy, and as well as on my website, which is itelcotech.com. On Udemy, I'm giving a offer on it to the users who are watching this video and who will use the link which is given in the description below in this video. You can avail more than 35% of the discount on this particular course if you enroll now. I would highly recommend you to go through it because it is one of the highest rated particular course on 5G on Udemy platform. Have a look, refer to the link which is given here, enjoy the benefits and learn the technology. Happy learning!